Hello, today is the day that we start proofs. So lesson 2.6 is algebraic proofs. You guys will be able to use algebra to write two-column proofs, and we'll use properties of equality to write geometric proofs. So we have properties of real numbers. These are things you've seen for many years. We have addition property of equality. This is when we add across the equal sign. Subtraction property of equality is when we subtract across the equal sign. Multiplication property of equality is when we multiply across the equal sign. Division property of equality is when we divide across the equal sign. Reflexive, symmetric, and transitive property we will see probably a total of 6 more times in different scenarios the rest of this year, maybe more. The reflexive property is when something equals itself. The symmetric property is when two things equal each other, and then you flip them, they're still equal. And transitive property is when you have A equals B, B equals C, then A equals C. Like our last lesson in 2.4, this is sort of similar to our law of syllogism. And then substitution property of equality is when you can replace a variable for another variable because they are equal. We also use substitution property for other things as well. You'll see in just a minute. Then we also have distributive property where we distribute a number or a letter through to the other ones. Okay? So, we're going to start with a proof. We always start by, well, first of all, labeling them, and then writing our given. You should never miss statement 1 and reason 1. These are what we are given. And then our reason for the first one is always given. Never miss it. Now, for these ones, they're not too bad because you literally solve them like you would for any algebra problem. So you know, oh, Miss Coates, I'm going to do this as a distributive property. Well, write it. That's your reason. So you can shorten it to distributive property of equality if you'd like. Now, it's kind of different. Usually we just do this step in our head, but we need to see everything going on behind the scenes too. So we will write all of this out. I know it seems pretty crazy. It's like, why do we have to do all this work? It's because you forgot that you used to do all this work all the time. Now you're just gotten so good that you're doing it in your head. But we need to write it down so we can prove it. Okay, so that was our distributive property. We distributed 2 through, we distributed -4 through. Now, we can go ahead and solve like we would have done in our head originally. Here's where we use that substitution property. Seems kind of silly. We're not really substituting in, or at least it doesn't feel like it. But I like to say if you're not really sure what you should do and you just did some sort of operation, in this case we did a bunch of multiplication, we use that substitution property of equality. This isn't multiplication property of equality because that only works if you're multiplying across an equal sign. We just did it on the one side, not across the equals. Okay? So now, if you were to solve this problem, you'd probably go ahead and combine like terms. So combining like terms, if you saw on the table above, was not one of our properties. So this once again will be substitution property of equality. If you're doing them with me, you can just go ahead and copy this over if you want. We're going to use that a lot. So we use substitution to combine like terms. Now, think to yourself, what would be the next step? And what I would do is I would add 18 to both sides. So I need to show that out. by adding 18 to both sides. This, because we did it on both sides, would be the addition property of equality. And then to actually solve that addition, we go ahead and once again use the substitution property. Now you're like, wow, I'm almost there. This is great. It is great. We go ahead and divide. Ooh, where did I get off? I need to rewrite this again. This is actually step 7. So we can't just put it on here. Makes it get confusing. Rewrite it and then divide. There we go. This is our division property of equality. And then finish solving. Once again, this is our substitution property. And we're done. So once we have proven, because we're asked to solve and we justified each step, we can put a little box here and we are good to go. Okay? So basically proving these and writing our reasons is just justifying what we did for each step. This next problem is very similar. Okay? So we'll go through it. I write out my given. And then I write the word given for my reason. I start distributing. Ran out of space. Let me move this over. All right. Now, that was my distributive property. Once again, I'm going to use my substitution property of equality to solve this guy out. Paste him down here. Then you would probably say, well, I'd combine like terms, so let's do it. Once again, when we combine like terms, that's also our substitution property. Pretty crazy, I know. What would you do next? It's actually the only reason that's different from our previous problem. Instead of using addition property of equality, we are going to use subtraction property of equality to subtract 6 across. Okay, then bring it down. So basically when we bring something down and solve like that, that's our substitution again. Then you say, well, I'm gonna divide. Me too. Oopsie, I did that again. We wanna rewrite it. Step 7. Here's where we divide. Okay, I just want to reiterate as we finish solving this one up that proofs. I know a lot of you have told me, my whole family doesn't like it, or I don't know how to do it, or this is so hard, it's such a lot of writing. Well, the lot of writing is true, but the rest of it, I think we can overcome, okay? So the statements, basically you're just doing the algebra on these. If you were gonna solve this out, how would you solve it? That's what your reasons are. I'm just wanting you to think about what your justifications are for each of these, and then that's your proof. It's really that simple. You solve for the variable, you write your reasons beside it, okay? Nothing really super crazy, okay? Now we do have one more where we're gonna add a little bit of geometry in after this slide, okay? So geometric proof. Since geometry also uses variables, numbers, and operations, many of the properties of equality used in algebra are also true to geometry. For example, segment measures and angle measures are real numbers, so properties from algebra can be used to discuss their relationships as shown in the table below. So I told you, reflexive, symmetric, and transitive would come back probably 6 more times. Here's 2 of them right here. Segments and angles both hold these properties. We're going to use that. So we are given if the angle FGJ is congruent to JGK and JGK is congruent to KGH, then we are trying to prove x equals 6. We're going to write a 2-column proof to verify. So we have statements over here and reasons on the right side. Now, if we were to just pretend we weren't proving and we looked at these 2 angles are congruent, and then we knew that these 2 angles are congruent, you would say, okay, well then I'm just going to set 6x plus 7 equal to 8x minus 5 because those 2 angles must be congruent. Now in your head you did a bunch of different things and you decided that those were equal based on the transitive property, and now I just solve. Super simple. We're just going to write out our statements and our reasons here. Now we need to write our whole given. Yes, it's long, but I do believe that you can do this. FGJ is congruent to angle JGK and angle JGK is congruent to angle KGH, and the measure of angle FGJ is equal to 6x plus 7, and the measure of angle KGH is equal to 8x minus 5. That reason, simple enough, is always given because that's what we were given. Now the thing we are trying to prove is that x equals 6. Okay? Now if you recall, from way at the beginning of the school year, I told you that angles being congruent is different than the measures of angles equaling each other. So we need to make that distinction here, that congruent angles have the same equal measures. All right, so this is the only reason that's not on the list that we're going to use, and that is the definition of congruent angles. And I would highlight that we're going to continue to use this throughout the year. Definition of congruence, sometimes angles, sometimes segments, sometimes other things, but that will come back. So definition of congruent angles tells us we can go between congruence here. We can go between congruence and measure equality. That's what it tells us. We can also go from measure equality back to congruence, so we'll use it a bunch. Then, as you probably thought right at the beginning, we can use the transitive property to say the measure of FGJ is equal to the measure of KGH. And that, as I said earlier, is the transitive property of equality. All right. Now, if you look back up at the top, you'll notice that the measure of angle FGJ is 6x plus 7, and the measure of angle KGH is 8x minus 5. So, by what we would say is the actual substitution, although we use the substitution property a lot, by the substitution property, we can replace these guys with their expressions. True? So that is by our substitution property of equality. Now we go ahead and solve. So we're just going back to our algebra rules. I'm going to add 5 on both sides. So this is our addition property of equality. Then I need to finish that out. And that, once again, when I do that sort of step, is a substitution property of equality. I'm going to go ahead and subtract 6x on both sides. So this is my subtraction property of equality. And then I need to finish solving it out. So we have 12 equals 2x. And that is once again by our substitution property of equality, because I did some solving. And then I can use my division property to go ahead and divide. So that's the division property of equality. Almost there, bet you noticed too. And we end up getting 6 equals x. And this is by our substitution property of equality. But we're not quite done. There is a distinction I want to make. It asks us to find x equals 6, and we found 6 equals x. You're probably like, so what? It's the same thing. Well, in proofs we got to be very particular, so we technically would need one more step that says x equals 6. And that would be our symmetric property of equality. That is an example of when we would use that property. And then we're done. So we add our little box at the bottom to show that we have finished this proof, and we are good to go. Right, hopefully you're feeling pretty good about these. If not, watch the video, look through them again. They're not too bad, just take them one step at a time, solve your math, and then explain your reasoning. Have a good afternoon.